understands everything that's in it, right? And so my first book was a question and answer book on the universe, and I wrote it in a playful way. I had a pen name for it was Merlin, Dear Merlin, how does the universe. Ice on top, but down below, you could be doing the backstroke in your warmed hot tub. So this notion that we want to look for planets and look for a habitable zone, the Goldilocks zone, may be needlessly restrictive as we go forward.
So now how have your intuitions been pushed around with respect to the prospect that we are alone versus the prospect, seemingly equally astonishing, that the galaxy and the universe is teeming with life? Have you had changes in the way you weight those probabilities over the course of your life?
Yeah, that's a great way to ask that question. I would say the probabilities have, as they've changed only because we learned new things, so not because I had to reevaluate what I was already thinking. I've always been very open to possibilities of the universe, just given the size and the as abundant. So carbon is already going to be at it before silicon, figures out how to put on its pants in the morning. And so I don't need to really think of life forms based on an isotope of bismuth or even silicon. So I think carbon is the way to go here, just given its diversity of chemistry that it offers us. And I don't know if I directly answered your question. Oh, have I changed any of my evaluations? Yeah. So the Fermi paradox is what you're dancing around there. And I want to clarify the Fermi paradox because I think most people who invoke it don't know the full weight that it carries. All right, so you can do the thought experiment. So Enrico Fermi, the physicist, famously quipped, if there's life in the galaxy, then the galaxy ought to be teeming with life, and they would have visited us by now. Where are they? Okay? So maybe they're not there at all.
It might be worth spelling out why that seems so logical. I mean, just with respect to any kind of time window in which...
Exactly.
Yeah.
So you can ask yourself, well, how wide is the galaxy? So 100,000 light years. Okay. So that feels intractable. So let's say you never get to the speed of light. But let's say we get to 20% the speed of light. That means you can cross the galaxy in 500,000 years. All right. But most stars are not the diameter of the galaxy away from each other. They're much nearer. So, for example, Alpha Centauri system from Earth, 4 light years away, 20% the speed of light, you get there in 20 years. Okay? And you can star hop. So, imagine, this is one of those, I forgot whose machine they got named after. You go to a planet, and then it's with a robot, and then the robot builds 2 copies of itself, and then they launch to other planets. Okay? And so, or even people, or aliens. So they arrive on a planet, and then they say, okay, time to go to more planets. And now you go from 1 planet to 2 to 4 to 8. They're star systems. It turns out, if you did that, only going to 2 once you land on 1, you can, it's 2 to the n power, right? So however many years are loaded in your n, you can easily completely populate the entire galaxy in an evolutionary timescale. Easily.
Yeah.
And so, you can do it within a few, tens of millions of years. But the planet is around for billions of years. So where is everybody? That's the question. And
the other intuition, the other element to this picture is that if complex life is ubiquitous, you would expect certain civilizations to be millions of years ahead of us. I mean,
offspring and they colonize 2 planets and they go 2 planets. Whatever that drive is, has the seeds of its own unraveling built within it. Because what happens when the planets start becoming scarce? Your urge to do this, risking life and limbs, that means it's deep in you. You need that planet. You want that planet. And so you go out and then there's somebody else trying to claim the planet, and then you have interstellar warfare. Competing over the limited real estate of the planets in the galaxy.
Yeah,
and then you think there's
a version of the Great Filter argument that I believe is original to Nick Bostrom. He's certainly spoken about a lot. He might have gotten it from somebody else, but I think it's Bostrom. But the more generic idea here is that it puts most of the onus on technology. It's just once you get technically sophisticated enough, you have almost certainly built destructive technology, and whether this is specifically weapons of war or artificial intelligence or something that gets away from you, and sufficient technical prowess to colonize the galaxy becomes self-terminating, almost by definition. I mean, there's too many ways to kill yourself and to have all your incentives as a species not aligned that you self-extinguish.
So I would say that would be a subcategory, or maybe they're both categories of the self-destruct phenomenon in high intelligent creatures. Because what this specifically implicates is the same urges that infused colonial Europe, right? So here you have Spain, Portugal, England, the Netherlands, and they all want to conquer the world. So initially they have their own territory, but then they encounter each other. And then the entire system implodes because they can't share it, because in them they want to own it. And so this notion has already played out in this world. And that was the implosion of Europe and its colonistic ways, going from the age of the great explorers to the age of the great collapse of the colonial empires. So it's not a stretch to imagine this as sort of a fundamental truth without having to analyze the psychological profile of the alien. It's just one of these basic, simple facts that might manifest no matter the life form.
Well, to back up for a second and to bring it back to Fermi, how has your sense of the proliferation of life, or lack thereof, changed once we discover things like amino acids in meteorites and in the tails of comets, which is to say that the building blocks of life seem fairly ubiquitous?
Yeah, and that's part of what we all find encouraging for those who are rooting for life elsewhere, because they can encapsulate that statement in a simple fact. If you rank order the abundance of chemical elements in the universe, the number one element is hydrogen. The number two, which is chemically active. The number two is helium, which is not chemically active, but it's there. So it's a big number two. Number three is oxygen. Number four is carbon. Number five is nitrogen. Oh my gosh.
Yeah.
So,
everything's on the
four out of the five top elements in the freaking universe.
And the seventh is a ham sandwich.
are contained in what we call biochemistry. And so that's why, like I said, if we were made of some exotic, like I said, an isotope of bismuth, you might have an argument to say God did something special on Earth because this stuff is not found anywhere else. But if anything, life is opportunistic. Okay? It makes very good use of what it has, and one other fact, which is not often cited, but it has to be in the equation, is the earliest fossil evidence. It comes in of life. It comes in around 3.8 billion years ago, and Earth began 4.5, 4.6. So for the longest while, decades, people subtracted those two numbers and said, all right, life took 600 million years. That's still pretty fast, given that we're 4.5 4.5 billion years old. Okay, that's still pretty fast. It's small compared to the life expectancy of Earth. But it's even better than that. Again, I'm value judging the speed of this. Because the early Earth was subjected to what we call the period of heavy bombardment. There were two such periods. Heavy bombardment, Earth is still, the polite way to say it is, accreting matter from the nascent solar system. The more violent way to put it is being slammed constantly by comets and asteroids because it has a strong gravity in its region, it's clearing out its orbit, and all that material ends up going somewhere and it lands back on Earth. And so the Earth is gaining mass, and by gaining mass it gains even more gravity, it becomes even better at it, and over that time, Earth's surface is sufficiently pelted that the temperatures prevent the formation of complex molecules. Because under high temperatures, the molecular bonds break. And every time you try to experiment with it, it gets broken apart. So it's not conducive to the experimentations of life. So if you're going to start the clock, wait until the period of heavy bombardment is over. That's like 4 billion years ago, not 4.6. So now you start the clock. Now Earth has some chance of cooling down and making complex molecules and starting the birth of biochemistry. And there it is. Earth went from organic molecules to self-replicating life within between 1 and 200 million years in the early universe, in the early Earth. And that's stupefying. So if it did it that fast, using native ingredients on a planet just formed like any other planet, then no one who studied this problem is walking around saying we're alone in the universe.
Although there is the additional improbability, whatever it is, of getting from life, single cell and I guess multicellular, to technologically advanced civilization. I mean, you can argue that we have barely accomplished it, and there's really no sign, but for us, there's no sign of natural selection producing anything like civilization without us. So again, we're sampling this in a very narrow time window, and who knows what the next million years might bring. But I guess let's sharpen up the Fermi intuition here. If you had to bet or assign a probability to one of two outcomes, or one or two states of affairs, one, we're alone with respect to complex life or technological sentient civilization built-in life. So there might be microbes elsewhere in the galaxy, but there's nothing like us pining for other star systems. us pining for other star systems versus the galaxy was or is teeming with advanced life, and for whatever reason we don't see it, which seems less astonishing to you or less unlikely?
Yeah, I have to think about it the way you worded it, but because I don't entirely agree with what part of your premise. So look at beavers, right? Beavers are mammals. They have large brain, like relative to other branches on the tree of life, and they fully exploit the resources in their environment. Oh, there's a tree. I'm going to use that tree to dam this river, and I'm going to make an underground dam. All right? Are we any different from that? We use trees. Well, first we use grass to make huts. That was available. Then we used trees. That's pretty convenient. Then we found metal. Oh my gosh, let's use that. Okay? And then we learned how to make alloys. Let's do that. And then we learned chemistry. Let's do that. So, yes, it takes thresholds of intelligence to exploit your environment even more. But the simple act of exploiting an environment is not unique to being human. That's my first point. Second, the Romans were no less smart than anyone who followed them. All right? Smart in terms of what their brain could figure out. But they didn't have alien communication technologies. They didn't have radio telescopes. They didn't go into space. So imagine the Roman Empire and aliens are waiting for a return signal back through space. And no return signal. So they'll say there's no.
They're still trying to do arithmetic with their Roman numerals. That was the problem.
Yeah, they needed the Arabic numerals for that one. Yeah, but people forget that Roman numerals do not have a zero. Yeah. You cannot represent a zero with Roman numerals, and that's why the calendar, the Christian calendar, Gregorian calendar, and the Julian calendar, there's no year zero. It went from 1 BC to AD 1 because no one could wrap their head around it. So yeah, the arithmetic is hard. I think they would have figured something out. I think they were smart.
In the fullness of time. You know, I mean, I take your point, and we should be humbled by how much change can occur over vast timescales, right? I mean, you look at the rest of what's on Earth with us now, and it's hard to imagine anything evolving into the kind of species that could do more than we're managing to do. But we're just looking at asynchronous lines of evolution, right? And given billions of years, basically everything is potentially available.
And millions is short compared with billions, right? A billion is 1,000 times longer than a million. And here we were, some kind of fist size or smaller shrew or some kind of rodent running underfoot, trying to avoid becoming hors d'oeuvres for T-Rex. And that's how it would have stayed if the dinosaurs didn't just get unlucky. And an asteroid takes them out, pries open the niche, an ecological niche that allows mammals to evolve into something more ambitious than a rodent. Meanwhile, rodents are still among us. So I want to impress upon people, if they didn't otherwise sort of wrap their head around it, that we went from rodents to humans in 65 million years, and that's a vanishingly small fraction of a billion years, and Earth has been around for 4 billion years. So now here's the tricky part. If you line up, this is a little thought experiment, if you just lay Earth's timeline out on the wall, left to right, beginning to end, and then you blindfold yourself, like, pin the tail on the donkey, and then you walk up to it, you don't know where you are, and you pin the tail. Most of the places on that timeline you pin it, Earth only has single-celled life. Complex life was relatively late, last 500 million years. And then what we call intelligent life in big brain mammals, even smaller than that. The point is, if Earth is any indication, if it ever gets to that, then it's fast. So imagine it got to that sooner. Or the other side, flip side of that is, imagine the asteroid never came. There'd still be dinosaurs here today. You know how I know that? Because dinosaurs were around as a community for 300 million years before the asteroid. So what's another 65 on top of the 300? They'd still be here. So what this tells us is what we think of as intelligence clearly is not important for survival. Otherwise, roaches would have really big brains, right? So maybe the big mistake here is thinking that intelligence is an inevitable consequence of evolution, when all it would have taken was one broken branch. Then that could have taken out all the mammals from the vertebrate chain, and then we would not have anything like we think of today as intelligent creatures.
Yeah, but if you run this experiment billions upon billions of times,
Well, there you go. That's the answer.
as long as we have, on the assumption that we're in no way unique, and we being species of Earth, and if multicellular life is ubiquitous in the galaxy or in the universe, and you just have those hundreds of billions, ultimately trillions of similar experiments to run, then it's very difficult to imagine that you don't have, at minimum, tens of millions of cases of advanced technological life.
That's how you get to win the argument in the end. You say, oh, what are the chances of that happening? 1 in a million? Okay, 1 in a million, and there's 100 billion star systems out there. So run the numbers.
Yeah.
You know, no one is thinking we're alone out there.
Yeah, but is that actually the opinion in the field? If you polled people at a conference of physicists and astrophysicists and astronomers, you think a large majority would say that advanced life is ubiquitous in the universe?
I think the only sensible way to do it is to just, we have a sample of one, so let's just start with that and ask, what fraction of the total timeline of Earth has Earth had what we would call intelligent life, or big-brained life?
Yeah.
And what fraction of that period has it had intelligent, the Drake equation, and what fraction of that period has intelligent life with technology? So if you do that, then that gives you a set of fractions that you can layer onto the entire stellar population of the galaxy. And even using highly conservative estimates, you do not come out with us being the only life form around. And like I said, if you look at the actual map of the galaxy where we have found these 4,000 exoplanets, it's this tiny little circle around. The star has to be close enough to get good data to know whether it has another planet around it. And you say to yourself, gosh, this is what leads to that analogy that comes from the SETI Institute with Jill Tarter and Seth Shostak, where they say, if you're going to say, well, have we found life? We haven't found life yet. And that's like taking a cup, an empty glass, and scooping it into the ocean and pulling it out and saying, the ocean has no whales. From this tiny sample of the vast ocean that you know you have yet to search.
Yeah. What do you think the limit is on getting a truly optical look at an exoplanet? I mean, any of these large telescopes that you describe in your book coming online, how close are we to seeing anything of interest in another solar system?
Yeah, that's a great question. So you can ask, let's ask it another way. If you're on the moon, how well can you see sort of cities on Earth? Not very well. Those images you see on the screensavers where you have the space station orbiting, you know, they've pumped up the brightness of those cities so they can stand out as beautifully as they do. But if you're going to go 250,000 miles away from them and stand on the moon, they become much less visible. And that's our nearest neighbor in space. To allow me to quantify this, imagine a schoolroom globe. And I'm always sad because there's always color-coded. And so you think of Earth as a place divided by countries, not unified.
Stuff that has leaked out, and the media has seized upon this really prominent stories that were not at all skeptical and not marshaling any of the legacy of skeptical debunkings of this kind of material in their reporting. So we have 60 Minutes and the Washington Post and the New Yorker, the New York Times. I mean, it's really more or less everyone in sight has given a very fair and one might even say credulous hearing to these reports. to my eyes, it's just not really clear what's going on. I said this on someone else's podcast, on Lex Friedman's podcast, that I had received a sort of an advanced communication, advanced with respect to the calendar, not with the details, that this was coming, and I was urged to sort of prepare my brain to receive these startling disclosures so that I could help shape a public conversation about this new consensus, which purported to be, again, it seems to me the shoe really never quite dropped, and I want to get your opinion on this, but what I was asked to anticipate was that the people who are best placed to assess the evidence, the people who have the radar evidence, the Navy pilots who have the dash cam video, the analysts who have pored over these data for now several decades, they have formed a consensus that there's
言うなのとか言うんで